focus on sustainability. In like we have consumed more resources than in the previous history in the last 50 years, and total 60 billion tons of resources are extracted annually, which is much like a 50% more than just 30 years ago. And the much fresh water has been withdrawn in the last 30 years. And we can see a worldwide metals production grew by 6 times during the years 1950 to 2005, and oil consumption by 8 times, and natural gas consumption by 14 times, along with the population, which is grew by 2.25 times. So you can see here it's a graph like a sustainability frame of reference where the rate of consumption versus the present time. So you can see that
Excuse me, ma'am. No slide is changing.
Slide
Madam,
is
go
not.
to slideshow. Madam,
No.
go to slideshow.
Sorry to interrupt.
Sir, I am in the slideshow only.
No, but we are not in slideshow.
Till now, only first slide is there.
Yeah, same. I thought you are giving something
yeah.
has come.
Okay.
Yeah.
So,
Yeah, go to slideshow, ma'am, or maybe.
Yeah, slideshow is still not there.
actually, now, sir?
No. Slideshow, if you click it.
Yes, sir. I am actually in the slideshow only.
No, it is not. It is not.
Ma'am, do one thing. Go to press Windows P.
Windows P.
See whether it is whether you are in duplicate mode or extend mode.
Okay, fine, sir.
Maybe you can change the other thing.
Yes, sir. PC screen only. Yeah. Thank you,
No,
sir.
not PC screen.
It is in duplicate mode now, sir. Now, can you see?
No. Go to extend.
Sir, it will work with the duplicate screen only, sir.
Okay. Then guide here. Yeah.
Extend?
No. See, make a slideshow, ma'am. Negative symbol. Bottom you can. Yes, that one.
Now it came, sir?
No. Ma'am, have you changed the settings, display settings to duplicate setting, duplicate slide?
Yes, sir. I have changed.
I think if you stop sharing and once again share, it will be corrected.
Yeah.
Because there is no law, but
Close and open.
But it may correct.
PPT is just close and open.
So many disturbances. I'm really.
Actually, I also have been facing with the Meet many times. Whenever I present, it creates so many.
Ma'am, just close it down and open once again.
Whereas
the PPT,
Zoom
PowerPoint.
is much better.
Okay, so once I'll again keep in the duplicate. Now, can you see?
No.
It is not.
Changing?
No.
No. So shall I stop sharing and?
I think that is only the layman method.
Redo, ma'am. Once again, you do just close it down this PPT and.
Yeah, same thing.
So, can you see, sir, now?
No, please share your screen, ma'am. You have stopped sharing.
Can't share your screen. Sorry, an error has occurred when sharing. Okay.
Madam, can you send your presentation to Santosh?
Yes, sir.
Yeah, that you do. That would be better. Yeah.
So now you can.
Just share your PPT to any one of us so that we can change your slides.
Okay, it's showing something. Okay, sir, I'll share. Santosh, sir, can you give me a hi message from your?
Yeah.
Please share in the resource persons group, ma'am. Otherwise.
Okay, then that will be better, sir.
Yeah.
Shade, sir.
Yeah. I guess all of you able to see my screen.
Yes.
Yeah, go ahead, ma'am.
Yes, sir. So can you change the next slide? Yeah, next. So these are the, yes, sir. So the why focus on sustainability is because as we are humans consuming more resources than in the previous history, like in the last 50 years. And total like 60 billion tons of resources are extracted annually. This is 50% more than just 30 years ago. And the fresh water is withdrawn in the last 30 years. And during 1952 2005, the metals production is grew by six times, and oil consumption by 8 times, and natural gas consumption by 14 times against the population, which is grew by 2.25 times. So next, sir. Next slide, sir.
Yes, yes.
Yeah. So this is a graph, the sustainability frame of reference, where this dots, black dots, it shows this is the sustainability rate. But as the consumption has increased, such that this is the red line indicates the today's rate. And now, in order to reach the sustainability, this is the slope that we need to follow. So this is the gap that one need to cover up. Next one, sir. So in order to come like from this red slope to this green to reach the sustainability rate, we need to use like 4 R's, that is reduce, reuse, recycle, and remanufacture. So these are the 4 R's that the technology wedges we can say that we can need to use to have this, to follow this sustainability rate. Next, sir. So like what do we throw away annually? So we throw like more than 434 million tons of waste. So like each person, if you calculate, like if you see, look at it, it throws about 500 kg of rubbish. And like every average family consumes around 330 glass bottles or jars. And household throws away 675 cans annually. An average household throws away 208 kgs of waste paper, and each person consumes 1 ton of wood. So these are what actually we throw away. Next, sir. So the glass, the average glass bottle contains over 25% of recycled glass, and 80 million fluorescent lighting tubes go to landfill each year. And in the same way, plastic, this is we completely depend upon the plastic. So every year, an estimated of 17 billion plastic is thrown away. And this is equivalent to over 290 bags for every person. And in the case of oil, 1 liter of oil can pollute 1 million liters of fresh drinking water. So this is what we throw away. And here the consumption of wood, like consumption of about 3% of global wood with only about 1% of world's population. And the land is completely filled every year with 20,000 batteries, and it can take up to 50 times more energy to produce a battery. So this textiles wise, the clothing, like 25% of textiles are currently recovered. So of these, 43% became second-hand clothing, and 12% are for wiping clothes where they are used, and 20% for filling materials, and 7% for fiber reclamation, and 9% are used for shoes making, and the rest of the clothing is 2 to 4% is rejected. This is what we throw normally in our daily life. So next one, sir. So now coming to the materials, the aluminum, by recycling 1 kg of aluminum, that what we use in the manufacturing, like it will save up to 6 kgs of bauxite, 4 kgs of chemical products, and 14 kilowatt hour of electricity. And recycling of aluminum requires only 5% of the energy, which produces only 5% of the CO2 emissions. And compared with primary production in 1989, 2% of all aluminum cans were recycled in 1998, and 36% of all aluminum cans were recycled. So this is like compared to 1989 to 1998, the percentage of how much aluminum cans are being recycled. Next, sir. And the similar way, like recycling 1 ton of steel saves the 1 tons of iron ore, 0.5 tons of coal, 40% of water. And we can see the recycling of 1 ton of paper saves at least 30,000 liters of water. And the electricity is from 2,000 to 4,000 kilowatts of electricity, and which can reduce 95% of air pollution. Next, sir. So coming to this, materials for sustainable manufacturing, the topic is, so what is a material? So material is a substance or a mixture of substances that constitutes an object. So this is the definitions. So before going, we have to understand the material life cycle. That is like acquiring the raw material, processing and manufacturing of this raw material, and packaging and distribution to the consumer, and the consumer usage, and end of life disposal. So these are the 5 stages of a material. Next, sir. So what makes a material not eco-friendly? Like if acquiring the raw material is irreplaceable and hard to extract, then it is not eco-friendly. And in the processing and manufacture, if it polluting and generates the waste source. And in the case of packaging and distribution, if it is very far from the market or needless marketing, late packaging. And in the consumer usage, if it is having a short product life. And in the end of life disposal, if it fills the completely landfill, then it is mentioned as a not eco material. Next, sir. So what makes it a material eco? So it should be easy to access. The material, raw material should be easy to access and quickly renewable. And in the processing, low energy is required for manufacturing, and no waste or pollution. And in the case of packaging, local, unpackaged, and long life cycle. And consumer usage, it should be non-toxic, making very small quantities. And end of life disposal, it should be biodegradable, reprocessable, and kept from waste stream. So these are all the features that makes a material eco. So what would be the most uneco material possible? Be like where which is having a limited supply and large scale permanent social, cultural, and environmental damage and instability. And we have a very forced low wage labor to produce. And if it is need to get it from very far away, and if it is toxic in use, and if it is decomposes very slowly. So these are all the features that makes the material uneco. Next, sir. So, so how the eco material will possibly be like it comes from just like beyond your front door, quick growing, low embodied energy, and no waste produced in converting from raw to useful, and no need for additional packaging, non-polluting and non-toxic. So all these features, and biodegradable, the most important. So all these features make the material eco-friendly. So next. So these are the questions when we are buying any material, the questions that the supplier and the gauge that commitment to eco issues are: what environmental information do they provide about their goods, and do they generally provide information gladly or reluctantly, and are their goods certified in any way? Do they have an environmental policy? Do they have a health and safety policy? So do have an ethical or social policy? So these are all the specifications that we look for an eco material. Next, sir. So, or we can make our own sustainable material. So, like you have to waste anything, waste from the manufacturer, we have to look at it, and a byproduct of a manufacture, and offcuts or trimmings, pre-consumer waste, wasted packaging, post-consumer waste, broken objects. So these are all the one which we can identify as a sustainable materials. Next, sir. So these materials, now we can see the plastics, how the plastics, whatever the waste, the recycled into roads and many others. So this is one example where we can see like about Enin is the author, and Ital has carried the synthesis of carbon nanotubes via pyrolysis of different types of plastic waste. So these are the different types of plastics waste they have collected, and they have used the two-stage process to get this carbon nanotubes with the help of this plastics. Here they have hydrocarbon gases, liquid and car were produced by thermal degradation of this waste. And this weight of the gases products depends on the type of plastic waste, like it's a low density polymerethane, like a HDPE and single use plastic. So this is all they have taken. So they found that low density polyethylene is more comfortable in getting this carbon nanotubes. This is now in use. Next, sir. So you can also see the alternative materials to single-use plastics, where this is a bamboo, which is now replacing the plastic. And this is in a plastic from the hemp. Hemp is a plant which is used for making this plastic. So where you can see the how within the days going on, this bottle is being biodegradable. And the seaweed is nothing but which is a plant in the sea, which is floating on the sea. So using the seaweed also, they're used for making this like a transparent type of material, which is used for packaging purposes. And this casein is a say milk protein, which we get it, which will be white in color. And this is also used because nowadays everybody is having milk without any protein. So that is being removed from the milk. So that is again, we can recycle it for the purpose of this plastic, which the casein is used for making buttons and other different types of household items. So these are the different examples of the alternative materials to the single-use plastics. Next. So you can see the sustainable building materials and unsustainable building materials. So where the wood waste, recycled plastic, and straw, that is from the grass, that is used for building materials, which is being replaced. Like this is being replaced with the glass, steel, lead, asbestos, reinforced concrete, etc. And here you can see the bioplastic. So now the bioplastic is being emerging, like many scientists are in the activity research into this bioplastic. Like they take the plant raw material is be taken and it be made to pulp, and it's been transferred into the plastic, which is what we use for everyday life, like bottles, some containers, spoons, so etc. Next, sir. So now going forward, this is about the sustainable materials. Now going forward, why sustainability in manufacturing? So manufacturing is the most resource intensive processes of all human activities. So this accounts for 21% of GDP, and it is also, India is also expected to increase the share of manufacturing in the overall economy to 25% by 2025 from the current 16%. So sustainability in manufacturing is required. Next. So this is you can see that in 2025 from 13% to 16% in 2016, and it is targeting to 20% by 2025. This is a manufacturing share of GDP in the top 15 manufacturing nations. Next, sir. So this is a global manufacturing scenario where by 2025, how the India is being ranking globally. Next, sir. So here, according why sustainable manufacturing? Because the manufacturing sector accounts for more than a third of global CO2 emissions. So rising greenhouse emissions is the third most important global risk. So there are, for sustainable in manufacturing, there are a range of issues we need to consider, like product design, innovation, recycling, waste management, infrastructure, financing, etc. So these are the many things that we need to consider for sustainable manufacturing. So next, sir. So we'll look at the difference between the manufacturing and the sustainable manufacturing. So manufacturing is nothing but mechanical, physical, and chemical processes to modify the geometry, properties, and appearance of a given starting material in the making of new finished part or product. So this is a general definition, like coming from the raw material to the product. Whereas in the case of sustainable manufacturing, the creation of manufactured products that use the processes should be non-polluting, they should conserve energy and natural resources, and are economically sound and safe for employees, communities, and consumers. So this is the new definition of manufacturing. Next. So sustainable manufacturing process means that they generate minimum quantity of waste, demonstrating improved environmental performance and energy efficiency, while taking into consideration operational safety and personal health. So it mainly deals with the branch of sustainability, deals with economical, environmental, and social objectives of manufacturing activities. So next. So these are the popular words in the sustainable manufacturing, like green manufacturing, clean manufacturing, environmentally conscious manufacturing, environmentally benign manufacturing, environmentally responsible manufacturing, eco-friendly, and sustainable manufacturing. So popular words that are being used nowadays whenever we are going to get any product. Next. So these are the evaluation of sustainable manufacturing. So the starting is traditional manufacturing, that is the substitution based. And the next comes the lean manufacturing, where we concentrate on the waste reduction based. Then the green manufacturing, it is should be environmentally benign, and it is 3R based. That is nothing but recycle, reuse, and reduce. So these are all the three where the green manufacturing is involved. Now comes the sustainable manufacturing, which is innovative, and it is 6R based. So 6R means remanufacture, redesign, recover, recycle, reuse, and reduce. So by taking all these 6 R's into consideration and getting a product is the sustainable manufacturing. Next. So this is the manufacturing share of GDP, where the innovative 6R based sustainable manufacturing practices are based, and it is an industry 4.0, which is nothing but known as cyber physical systems, where it has been involved. Next, sir. So the sustainable manufacturing is measured and evaluated using the 6 sustainability criteria, like manufacturing cost, energy consumption, and waste management, operational safety, personal health, and environmental impact. So these are the 6 criterions are used. So the basic objective of sustainability is to minimize the manufacturing cost, minimize energy consumption, reduce environmental impact, improve personal health, improve operational safety, and improve waste management practices. So these are all the objectives. So coming to the economic performance, under economic performance, what are the parameters we have discussed? Like manufacturing cost, energy cost will be falling to, and environmental performance like material and water usage, energy consumption, restricted waste generated. These will come under environmental. And coming to the social performance, like health, happiness, education, poverty, standard of living, these parameters will fall into this social performance. Next. So this is related to operator safety, personal health, and waste management. Next slide, sir. So now how to implement the sustainable manufacturing. So there are like most on the technologies to developing the technologies and methodologies for reducing the emission of greenhouse gas, use of clean energy, improve energy usage, and reduce use of non-renewable or toxic materials, and reduce waste byproducts. Next, sir. So how to implement the sustainable manufacturing? So by improvement in work practices, you can say some five like in 5 ways we can implement the sustainable manufacturing, from generally easier way to the more difficult, like improvements in the work practices, then process optimization by making adjustments to the processes to increase efficiency, then raw material substitution, like shifting to more environmentally sound inputs, then by implementing the new technologies like enabling fewer resource consumptions, waste generation emissions, and to new product designs like minimize impacts through throughput product life cycle. So this will be going from the generally easier to the more difficult. So these are the ways to implement the sustainable manufacturing. Next, sir. So how the sustainable manufacturing in practice is using renewable materials that don't deplete the natural environment, and using fewer materials and inputs that are non-hazardous or recycled, and modifying production processes to use low energy, water, and materials to produce less waste. And here using less packaging, like lowering the product weight, using more efficient transportation and logistics, then designing your product to be reusable, remanufacturable, recyclable, or biodegradable. So these are the 4 things that we need to take care of over here when you're designing the product. Then expanding the life of the product, making it easier to repair or designing it to use fewer resources during the use, and working with the stakeholders like customers and retailers to reduce environmental impact of sales and distribution. So this is the how the sustainable manufacturing is in practice. Next. So we'll see a few cases where how the sustainable manufacturing practices will be taking place. Next, sir. This is a life cycle assessment. It is an environmental management tool that enables the qualification of environmental burdens and their potential impacts over the whole life cycle of the product, process, or activity, like identifying the opportunities to improve the environmental performance of a product at various stages of its life cycle. So next is
Sorry.
okay. This is the life cycle assessment, like a framework and the direct applications. How this go like a goal and a scope, like it is defined over here, and how the inventory analysis, impact assessment through the interpretation will be done in aligning with the product development and improvement, strategic planning, marketing, and any other applications. Next, sir. So this is how the stages of a product life cycle can be defined. So this is the raw materials transported to the industry, where manufacturing is done, packaging, and it is transported, and it is distribution and supply chain distributed to the user or consumption. And after usage, it will be thrown, whether it is reuse, recycling, remanufacturing, or disposal. Incineration also is there here. And natural resources, like we're taking more again more natural raw materials, and again going for the manufacture. So next. So this is the example of lamps. So how much the transportation, the bulk material manufacturing, LED packaging, and the use. So in the case of incandescent lamps, this is the usage is more, and this is the halogen lamps, and this is the CFL LEDs, and in the LEDs 2015. So the use has reduced. Okay, so this is what we can see over here. Next. So the
Madam, your focus on the talk is on which basis on the object?
sir, on materials and sustainable manufacturing, sir.
Okay. Material and sustainable
Manufacturing.
In the previous slide, just to go ahead.
Yes, sir.
Yes, on this, what the graph is telling?
So the use of this, there are different types of lamps, sir, over here.
Okay.
Okay. So the use has been reduced,
Only
sir,
that's
here.
from the energy consumption by the bulb only. This thing.
Yeah, this is the energy consumption, sir.
Is it in the industry application or manufacturing application, or is it a home application?
So whole, sir, we are taking into consideration the manufacturing application, sir.
Okay.
Okay, sir. So here the energy consumed during the production, like in the case of an example of a cloth, if you have taken it here, making of yarn or making of individual product or marketing of the product is 18% energy is consumed. And during use, like the water consumed either hot or cold, 79.5%. And to make the detergent use is 2.5%. So this is the case of the clothing. Next. So this is the life cycle assessment of a biodiesel production. So the CO2 emissions you can see here in the y-axis, and then the x-axis petroleum and diesel here. And this is the biodiesel blends, B20 and B100. So we can see the reduction in the carbon dioxide emissions with the biodiesel blends. Next, sir. So the environmental impact of manufacturing, if you see over here, is, so this is a auxiliary like working material. This is the manufacturing processes where the materials are input, and the output materials will be the products and byproducts, and the input energy will be the electricity and fossil fuels. So the output emissions will be greenhouse gases, various pollutants, and toxicants and solid wastes. These will be having an impact in like causing global warming, acidification, human toxicity, ecotoxicity, etc. So this is the environmental impact of manufacturing. Next, sir. So now we can see the input process output diagram for electrode discharge machining process. So here these are the inputs that we actually give for an electrode discharge machining, and the outputs like material removal rate, tool wear rate, surface finish, micro hardness, so etc. And so the sustainable manufacturing is being designed in such a way that if you have a control and optimization in the inputs, okay, then for achieving the optimal values of material removal rate and tool wear rate outputs, then we can rectify these hazardous gases, filter cartridges, low material removal rate. So these are all the rectified in the electrode discharge machinings. So the targets to achieve is environmental safety and reduce the manufacturing cost. So this is how the sustainable manufacturing is being used. Next, sir. So this is the environmental impact of electrode discharge machining, where the energy consumption will be 3.9%. For the exhaust system, this is for EDM process 47.3, and this is a case of workpiece material, and for the dielectric production here, and this is for process emissions. So this is a distribution of environmental impact during 1 hour of EDM. This is a roughing process where a copper electrode and hard metal workpiece is used over here. Next, sir. And so this is a example where a grinding process is there. So, so this is the energy which is used for the grinding process. So the processing energy, where we have a machining energy, peripheral energy, that is for cooling system for coolant supply. And here we have a non-product material and product material. So the non-product material can be, you can say, reused, and this product material can be recycled. So non-product materials will be like oil, emulsions or solutions here. And the tooling will be the grinding wheel. And the incoming part will be the quality, like material structure and quality of incoming part over here, the consideration in the product material. And here the machine product will be having surface roughness, surface integrity, profile dimensions, etc. will be the product will be measured here. And the waste, like a debris, chips, filter material, etc. And dirty cooling lubricant, gaseous emissions, and process heat. So these are all the different, like you can say, parameters or in the grinding process. Like other life cycle approaches for sustainable manufacturing are designed for sustainability, environmental impact, cleaner production programs, supply chain management, end of life management, integrated materials management, environmental management, and design for environment and environmental labeling. So these are all the other life cycle approaches. Next, sir. So here, these are some life cycle assessment tools that are being used here to evaluate the potential environmental impact of product, process, or activity throughout its entire life cycle. Like Zima Pro, Quantis, Umber2. This is being developed by PE International, etc. And SolidWorks CAD software. It provides the LCA-based environmental information to the user through an add-on called Sustainability Express. And PTC's Windshield Product Analytics makes LCA results an integral part of product development systems. Next. So next is the sustainability in manufacturing tool systems. So here, this is a machine design or manufacturing. They use the innovative concepts like hybrid machine tools. So that is, they use battery for initial operations and direct electric supply for cutting purposes. So
Sorry.
it's okay.
Should I keep that slide, ma'am?
And it's okay, sir.
Ma'am,
So-
for your kind reminder, we have last 10 minutes now. Yeah.
10 minutes time, sir. So I will go a little bit quick. So this is the machine design and manufacture. So like we use the machine elements like CFL bulbs will be used for conserving the energy, and design using sustainability metrics like and for reuse we'll design the component for reuse, remanufacturing, and component upgrade, and you will have a low maintenance. Next, sir. So this is the manufacturing process planning, where drill, turning, vertical for any product to have this done on the separate machines. So it is better to use one machine than the number of machine tools from an energy point of view, sir. Next one. And microprocess machining. So the controlling the feeds and speeds for minimum energy machining, and rough and finish plan for minimum energy consumables finishing, and the tooling design, and carrying a optimized tool path for high productivity and minimum energy, and minimize environmental requirements. Next, sir. So by optimum selection of cutting parameters, the CO2 emissions have been decreased with the spindle speed increase. And here you can see the energy with respect to the feed rate. The energy consumed is decreased with the optimizing, with the change in the feed rate. Next one. So this is how the real-time energy monitoring of the machine tools is done for load balancing over the line of system or over the plant, and the resource or consumable optimization. Next, sir. This is how the online energy monitoring of machine tools is done. Next, sir. So this is a use of water-based coolants. Like problem mainly is to dispose the waste coolant. So, and the coolant pump also consumes additional power. So environmental friendly machining processes will reduce the waste and power consumption. So minimum quantity lubrication or dry machining or cryogenic cooling. So these are the three areas which are being which are used for reducing the toxic emissions and minimizing the power requirement. Like minimum quality lubrication is called MQL. Next, sir. So next, sir. So these are the requirements of cutting fluids, which is usually used for the cooling the cutting tool, workpiece and chip, lubricating the chip, and the chip removal for and rust inhibition, and enhancing the machining quality by reducing the cost of machining. Next one, sir. So there is some quality, because of this kind of mist and everything, there is a change in the quality issues with cutting fluids. Next, sir. So they're highly vulnerable to microbial contaminants. Mist and vapor generated are harmful for the operator, causing lung diseases, and it may lead to direct exposure leads to skin diseases and respiratory-based diseases. So these are the issues and problems. Next, sir. So cutting fluid consumption is estimated like more than 100 billion gallons per year in US. The total cost of purchasing and disposal is more than $48 billion. So, and disposal and recirculation forms a major share of the cost. So here you can see the tool cost and the cutting fluid cost. The cutting fluid cost is more compared to the tool cost. Next, sir. So this is how the sustainability is increasing with this is coolants, petroleum-based metal working fluids, minimum quantity lubrication, vegetable oil-based, use of nanoparticle-based coolants, and dry cutting. So these are all the different how the sustainable solution is provided. Next, sir. And you can see this is how the MQL with nanoparticle added cutting fluids, how it is sustainability is being becoming like is incorporated over here. Next, sir. So this is minimum quantity lubrication. So you can see here, this is called as MQL cooling, and this is a flood cooling, where the more amount of coolant is used here. And in this case, a minimum quality lubrication, where the coolant is with force, but very less amount of coolant is used. Next, sir. So the goal is used to just enough lubricant in the case of MQL, and here to lubricant and coolant to remove maximum of heat and friction. So the flow rate is also, you can see 50 to 500 ml per hour. This is 120 liter per hour. So next one, sir. So these are the vegetable-based, different types of vegetable-based cutting fluids. Next, sir. And advantages, the biodegradability, low pollution of the environment, etc. Next, sir. So these are the research opportunities in cutting fluid technologies, like development of new vegetable oil-based cutting fluid and minimum quantity this cutting oil, nanoparticle mixed, and petroleum and vegetable cutting oils. Next, sir. So these are the research opportunities in rapid coolings, like in casting tools, forming tools, EDM tools, injection moldings, and other processes. Next. And in the case of additive manufacturing, the life cycle analysis of additive manufacturing process for polymers, metals, and composites, and modeling and simulation of material flow, energy flow in additive manufacturing. So sustainability, applying the sustainability, On these areas, there are much research opportunities in these areas. Next, sir. Sir, this is the end of my presentation. Thank you, everyone. Actually, I am in a rush, so I couldn't give more on the actual. At the ending, there are case studies where I am unable to give much presentation on this. Thank you very much. Sir, any questions?
The participants may ask if anyone having questions.
Madam, why sustainability is required? Though manufacturing are going in the right directions, why the question is arises on sustainability?
Sir, because of the material requirement is the one thing, and the energy, whatever it is, sir, the material again is into the energy consumption. So now the sustainability is much more important. Whatever the manufacturing is being taken place, the usage is also becoming higher and higher with increasing in the population.
Okay. Right. Thank you.
Yeah, thank you, sir.
And I request Ramakrishna sir, Dr. Ramakrishna sir, to summarize the session. Ramakrishna sir?
Yes, sir.
Yeah. Go ahead, sir.
Thank you, Santosh sir. Again, a very good evening, all the dignitaries here. And firstly, I'm very thankful to Dr. Anitha Lakshmi garu for giving a vast description regarding the materials, especially in the sustainable manufacturing. In by summarizing, she told first regarding focusing on the sustainability of the every material, and also how the population is, how the oil reserves are and remaining. Then Dr. Anitha garu told about the recycling process, especially mentioned 4 R's as reuse, recycle, recover, like that. Then she told about the what is general manufacturing, likely what is sustainable manufacturing. And in between, Dr. Anitha garu told about how the aluminum is recycling, likely plastic, and the remaining other materials are recycling, likely what are the advantages, likely what are the disadvantages, everything Dr. Anitha garu told, revealed very clear. Likely Dr. Anitha garu told about the material life cycle, and also the 5 stages how the cycle is. And finally, Dr. Anitha garu told about the revaluation of the sustainable manufacturing and different countries, what is the share of the manufacturing regarding sustainable manufacturing, and also told about the criteria what should be taken to produce this sustainable manufacturing materials, and how to implement this sustainable manufacturing materials, and also for that what tools should be required, and especially regarding that the life cycle assessment is discussed, and the framework is also discussed. Finally, she told about the minimum quality lubrication, what lubrication is required to produce that materials by using the concerned tools. And once again, thank you very much. And also on behalf of our team, I extend my heartfelt thanks to you, Dr. Anitha garu. Thank you, Santosh garu. Continue, please.
Thank you, sir. Thank you very much.
Yeah.
Thank you,
ma'am.
ma'am.
Participants, and thank you, ma'am, and thank you, Ramakrishna sir. And dear participants, and the assessment link is open, and please be online and open the link, follow up the link. If you have any queries in opening the link, if you have any issues, here Dr. Killi Durga Prasad is there with you to guide you. So go and give your assessment right now, and it will open exactly on 18:35, that is 6:35 p.m. and you will have half an hour to finish it up. All the best for the exam, and I mean, for your kind notice, you must score more than are equal to greater than or equal to 70% of the marks. 20 questions will be there, and you should get minimum of 14 marks.
And the assessment you have to give directly in the ATAL website where you have applied the FDP. No? So you have to visit the ATAL website. You have to click on the assessment link, and then you can see the if you have any participant in FDPs, that links will be there. The last one will be our link. So I have given the number in the chat box also. So just click on the link, and after 6:35 p.m. it will open. Okay, no? If you have any doubts, please text me like in the chat box.
After the test, the participants can also give the feedback.
Yeah, the session, I mean, after assessment test, we will be having feedback session. Please stay.
In the
Please stay-
ATAL also, they have to give feedback for the entire FDP.
Yes, yes,
ATAL portal.
yes.
Sir, feedback is to be given first, sir. It should.
Sir, according to the schedule and all, assessment test is 6:30 to 7, sir, and 7 to 7:30 feedback, sir. That is how it
Yeah,
is.
6:35 to 7:05 it is.
Yeah, 7:5, yes.
Santosh, maybe you can share the link of feedback as well as this thing of the URLs.
Okay.
Participants, make sure you log in with the same ID with which you have registered.
Sir, feedback, what is there in ATAL site, that feedback we have to fill, no?
Yes, sir. You can give that feedback there. That feedback is for the entire session, sir. So you need to give.
It is for manufacturing and industry 4.0, no? This one.
Yeah, entire FDP you have to give. Yeah.
Okay.